Welcome, everyone. Welcome to my talk, where I will give you an introduction and tell you all about the pitfalls of Java's new concurrency model. My name is David. I am a software developer in the Netherlands at Team Rockstars IT, and I have been developing software using Java for around 6-7 years now. And if you have any questions after the talk or during, somewhere this week, you can always find me on Twitter or at my website. There are multiple ways to contact me. And let's start with the outline. Before I start, I will go over the current situation of multithreading in Java. I will see what's possible now. How is the current threading model that we use? How does it work? Then I will slowly transition into what are virtual threads, how do they work, and how can we create millions of them, because that's the really interesting part. And then we have lots of virtual threads. We want to combine them into a unit of work. And then we slowly go into structured concurrency and see how that helps us. And at the end, there is some time for a Q&A. So if you have any questions, you can ask them at the end. So before I really start with my talk, I want to do is a quick word of caution. Everything you will see is just still a work in progress. However, the stuff you are going to see with virtual threads, that's mostly will stay the same until the 19th of September, when it will be mainstream with Java 21. But the thing is, with the structured concurrency, that is still still very much in development. So the naming might change, or some new methods might be added or removed. But the idea will stay the same, is that you can group threads as a single unit of work. But we will cover that later in the presentation. So let's start with the current way of creating a thread in Java. Can I get a hand up for everyone who has done something like this before? That's like almost everyone. That's really great. So what happens here is that we call the thread constructor and ask Java, can you create a new thread for me? And Java's like, okay, I can do that for you. I will make a call to the operating system and I ask it, can you create a thread resource? And the operating system will do this. It will reserve some memory, in some cases around a megabyte. And then we return inside our program. And at that moment, we have this operating thread that is managed by the operating system and that we can use inside Java. So the thread class inside Java is just a very thin wrapper around a thread that is managed and scheduled by the operating system. And we pass this little thread, we pass the task, and then we start this task. That's nothing really that exciting. And you may have noticed that we have platform in the name of the thread at the top of the title. And that is because we now call these kinds of threads platform threads. And that's to be able to tell the difference between the virtual threads that I will cover later and the current way of threading that we have now. And we call them platform threads because they are managed and scheduled by the platform. So these threads are there for the operating system to manage and schedule. And now let's go over and see how we can use these kinds of threads in our application. So here I have one way, and is that we have 3 different tasks. And for each task that I have, I create a single thread. I think most of us has been taught to never do something like this because it's just a waste of resource. We are not meant to create a thread to only discard it when a task is done. But it is a very easy way for us to program, because then we don't have to manage all these threads and pool them and see if they are available. But we can just create them on the spot, which is nice for us, but doesn't make the best use of the hardware that's available to us. And since Java 5, we are encouraged to use thread pools, using something like the executor services. And the great thing about the executor services is that it pulls these threads for us. The only thing we have to do is submit a task, and Java will handle the rest for us. And while this is very easy for us, we still only have a limited amount of threads. And when we submit a task, some tasks will still be waiting in the queue for a thread to pick up. And there are also some other downsides. For example, thread leakage. You're leaking your thread locals. For example, if I have a task that sets a thread local variable, and I forget to unset it, because those things happen, then this thread will be put back inside the pool, and this thread local will still be available for other tasks. So when this thread picks up a new task, it can read the thread local from a previous task. So at that point, you're leaking your thread local variables. And of course, when we have a thread that is blocked, so I have a task to query a database. And while we are querying this database, so this database is busy building our request, at that point in time, the thread that started that request is blocked. It doesn't do anything. It's just standing there. It's just a waste of resources, while it could do much better things. So while the executors are a great improvement over just using the thread class directly, they aren't really that ideal yet. And another way to improve on this is using async programming. For some of you, this may be some very hard opinions here on the screen. But in my opinion, async programming is very hard to write, because you have to avoid this blocking. It is very hard, well, in my opinion, it's very hard to write, even harder to read, especially after 2 weeks. And it's very hard to debug, because, well, Java is really built around threads. And async, well, you don't really manage threads in a direct way. And this is where virtual threads come in. Virtual threads want to make good use of the hardware that's available to us, but it also wants to make the life of us programmers a lot easier. And virtual threads, they aren't there to replace the current way of threading that we have now. So we still have the platform threads that we all love, but we just get a new implementation, so you can choose which one you want to use. So it isn't going to replace the old ones. And the great thing about virtual threads is that the operating system doesn't know anything about them. So when I create a virtual thread, I don't leave my application, so I don't go to the operating system. They are just a concept that lives within my application. So when I create a virtual thread, it's just like creating any other object. And another benefit, so that improves something on the speed, so I don't have to leave my application. But another great thing is that now my virtual thread, because it's just a concept, its stack frames now also live inside the heap. And this is a really huge benefit, because with the platform threads, the current way of threading we have now, is that I have to reserve 1 megabyte of memory for every thread that I'm going to create, which really adds up if I want to have 100, 1,000, or even 1,000,000 of them. But because virtual threads their stack frames live inside the heap, I can start with just a very small amount of memory. So just a few bytes. So that's a huge difference over the megabyte of memory that I would have to allocate for a platform thread. So the benefit really of this living inside the heap is that it can grow and shrink as needed. So because it is in control of the JVM. And it all adds up to being very cheap to create, which leads us to creating a task for every virtual thread. We can create a virtual thread for every task that we have. So we can have n-grade utilization of our hardware, and we can create a task or a virtual thread for every task that we have. So it's also easier to read and to use for us, developers. So in the next slide, I'm going to show you how cheap exactly virtual threads are in comparison to platform threads. So I made this little bar chart, which shows you how cheap virtual threads are. Just to give you some background information, I built the application. It started with 46 megabytes of heap space. And then I just started creating threads. So using the native memory tracker, I started to see how much memory is every application using. So and as you can see, at the beginning, when I have just one platform thread and one virtual thread, that's really hard to see on screen because the difference is very small. But platform threads are really, cheaper to create when you have just a single one of them. And when we go to maybe 10 platform threads and 10 virtual threads, even then still are the platform threads cheaper to create. But when we go to 100, the difference is now with the virtual threads. Now the virtual threads are a lot cheaper. So I have created 100 platform threads and 100 virtual threads. And then you start to see this very small difference. And then we go to 1,000. And then you see that the virtual threads doesn't really look like it has changed, just a small bit of memory more, but the platform threads almost doubled. And then we go to 10,000, and then it really goes skyrocketing. And then we can see that the virtual threads, well, just use a little bit more memory, and the virtual, and I'm almost out of memory with my platform threads. And the great thing about, well, when you want to create 100,000 of them, you can look at this in two ways. Or it's just very memory efficient to use platform threads, because your application will just crash. Or you can just use virtual threads, and you can create 100,000 threads, and it just uses a little bit over 225 megabytes of memory, which is just really nice. Because now it's just possible to run on a, well, very basic laptop to create 100,000 threads, while the machine was really screaming for me to stop when I just wanted to try and create 10,000 of them. So I think that's enough. Well, enough talking. So let's switch over to a demo, because that's way more fun to watch. So I'm going to create a single virtual thread. That's visible on screen. And like I said, the virtual threads are just an alternative implementation of the thread class, so I can still use a thread. And let's call it VT, which is short for virtual thread. But then I can't use the thread constructor. What I have to use is a static builder method called the start virtual thread. And I can pass it a runnable task. So in this case, I will give it the print task, which will print something to the screen. And then a join, so I can actually see it in the console. And as you can see, I just created a virtual thread that starts immediately, and it prints Hello Brussels to the console, which is really great. So another great thing with Java 21 is that we now get builder methods. So instead of using the static builder, I can also use a builder. And as you can see, you have the choice of using off virtual, which will create a virtual thread, and of course off platform, which will create the threads that we are already familiar with. So let's choose off virtual, and then I can set properties like, for example, the name, which I will call VT Brussels. And then I can give it either an unstarted task or a started task. And then it will immediately start it, but I will show you the unstarted task. And then I will just get a virtual thread that I have to start myself. And when I run this, it again prints Hello Brussels to the console. So now I have shown you how to create just a single virtual thread, and with Java, since Java 5, we are encouraged to use the executor services. So let's see what has changed there. So I create a executor services, virtual threads, executors, and I can use the new virtual thread per task executor. What this does is it will create a new virtual thread for every task that I submit to it. And as you can already see, IntelliJ lights up yellow, so it has a hint. And it is that with Java 21, the executor services now implement the auto-closable interface. So now I can do stuff like this and put it inside a try with resource statement. Oh, the wrong brackets. And then I can just submit tasks. So now I will let it print 3 times Hello Brussels to the console. And as you can see, it prints Hello Brussels 3 times. But I didn't have to do a evt.join or join on any of the threads, because before I can exit this try, all my threads have to be done running. So I don't have to do the join myself anymore. I can't exit this try before all my threads are done. So now that we have seen how to create just 3 threads, let's go and show something more exciting and show some big numbers of threads. So here I'm going to create 10,000 virtual threads. So what this for loop does, I can just throw this away. Wait, I can show you something better, I think. So, much nicer, but now I missed the for loop. So what this try now does is, well, I'm going to submit 10,000 times the sleep task, and the sleep task, all it does is just sleep for a second, and then it continues. So let's see what happens. And it's done running. So the great thing about this is that I now can start 10,000 threads that all seem to be running at the same time, because I didn't have to wait 10,000 seconds for this try to finish, or because, well, it's a, I think, 12-core laptop, so 12 threads running at the same time. Either way, if I have used the platform threads, I would have waited much longer. So now that you have seen how to create a lot of threads, let's go back into the presentation and show you how this all works behind the scenes. So how does this all work? Because I've shown you I've created the 10,000 threads on this laptop, but I don't have 10,000 cores, so how does this match? So at the top I've created, well, a bunch of virtual threads I want to run, but these virtual threads don't run directly on the CPU, so to speak. They run on what is called a carrier thread. And a carrier thread is just a platform thread that is there to run virtual threads. So each of my carrier threads gets assigned a, well, they run inside a fork join pool, and they all get some virtual threads they need to execute. So each of my carrier threads, in this case I have 4, will run through their own queue of virtual threads, and when one of them is done, it will just steal a virtual thread from another carrier thread. And the great thing about this is that now my carrier threads are constantly running, so my very expansive platform thread is always busy, but my virtual threads can just wait until they're ready to run on a carrier thread. And by default, you will get the same amount of carrier threads as cores available inside your system, but you can tweak that using a parameter on startup of your application. So there are ways to manage how many carrier threads you want at one point in time. So how does this carrier thread know which virtual thread to run, when and where? So I have a carrier thread, and on top of this carrier thread runs a virtual thread. So this carrier thread is executing this virtual thread, it is running, it is doing some calculations, and then something happens. This virtual thread encounters a blocking method. And when a virtual thread encounters a blocking method, it's being unmounted from its carrier thread, which means that it will be copied from the carrier thread back inside the heap, and the new virtual thread will take its place. So this virtual thread will be copied from the heap and inside this carrier thread. And then this carrier thread will start running. But not every method is ready yet. As I have said, when you encounter a blocking method, it will be unmounted, but it doesn't happen everywhere yet. For example, with the synchronized block, a object.wait, a call to native code using GNI, or even a file system operation, at those points in time, the virtual thread is pinned to its carrier thread, which means that it can't be taken off its carrier thread. This has to do with some code inside Java that isn't ready yet for the for virtual threads. So what happens is that your virtual thread will be stuck to its carrier thread. And then you don't get the performance improvement that you might have expected. And that brings us into the pitfalls of virtual threads. Well, as I have said, when you encounter a blocking method, then it will be unmounted. So if you are doing some long-running calculations that never encounter a blocking method, then it will never be unmounted. Then this virtual thread and carrier thread will just behave like a normal platform thread. And then in those cases, just use a platform thread instead. Another thing you don't ever want to do is pull virtual threads. They are not meant to be pulled. You just create them when you need to, and when you are done with a virtual thread, just discard them. They are really not meant to be pulled. Just if you are pulling them, then you have done something wrong in your architecture. So it's a really big mind shift that you have to make when using virtual threads. And of course, there are some code bases that use a thread pool as a kind of lock to limit the amount of connections to, for example, a database. At that point in time, you don't really want to use a pool, but just a regular lock instead. And of course, old libraries may not have been adapted yet and could use these unsupported methods or, well, any of these pitfalls. And that brings us into structured concurrency. And structured concurrency helps us managing threads as one single unit of work. And before I dive deep into what structured concurrency really is, because it's, well, kind of complicated the first time you see it, I want to start very simple with just structured code. I have a very simple Java method, it's called method A, and it calls two methods, method B and C, and then it combines their result and returns it to the caller. And the benefit of structured code is that it has a very clear path. I start at A, I call B, C, and then I get a result that I can return. All very simple and straightforward. And the best thing about this is when an exception happens, it's just very clear when my code is going to exit. So for example, if method B throws an exception, I know I don't have to execute method C anymore. I'm not going to try and create a result because I can't. And that's all very great. And the same goes for C. If method B succeeds, I have a value for B, but if method C throws an exception, I know I can stop and not going to try and create a result. But it gets a little bit more difficult when I add threads into this, because here I have the same method, but now method B and C return a value using a thread. So now B and C run concurrently. So I enter method A, I run method B and C at the same time, and I combine the result. Well, if no exceptions happen, it's great, it just works. But then exceptions start to occur. For example, if method B throws an exception, method C, well, is still running. I get that my foo.get, only then to find out that my method B has thrown an exception, and then I have to go after method C and try to stop that thread from running. And of course, the same happens with method C, but it's a little bit uglier, because then I have to wait for my method B to finish. So if my method B is running for 5 minutes, is doing some calculations, I'm waiting at the foo.get for my method B to, well, return a result. But only at bar.get I find out, hey, my method C has thrown an exception, I can't create a result, and I've waited for nothing. So then you're just wasting time and resources, while you could have stopped earlier. And of course, if the parent thread of method A throws an exception, or just interrupts, then you have two threads running loose inside your system, and you have to try and catch those and terminate them. So that's a little bit high over how structured concurrency looks like. So now let's switch into the demo and show you how it works. So there's a lot on screen, so I want you first to focus on this very first line. Because structured concurrency is implemented using the structured task scope. And the structured task scope has two shutdown policies. The shutdown on success and the shutdown on failure. And this policy states when do I want my threads to be terminated, and when do I want them to succeed. So I'm first going to show you the shutdown on success, which will return a string object, which means that all the threads I'm going to create inside my scope are going to return a string object. And of course, it's inside a try with resource statement, so I'm going to create my virtual threads inside this scope. So as you can see here, I use the scope object from the try with resource statement to create both of my threads. The first one will return result 1, and the second will return result 2. And the moment that I fork these threads, they will run inside a virtual thread and they will immediately start running. And my parent thread will just block at this join. At this join, I will wait till my virtual threads are done. Well, the first one really, because with the shutdown on success, I'm only interested in the first thread that finishes. So when these two threads run, I will wait at the join for the first thread to finish. The first thread to finish, well, will have the stage success, and the other thread will be terminated. And then using the scope object, I'm going to try and get a result from this scope, which will be the result of the first thread that finishes. I won't know which one of the threads finished first. I don't really care. But what I do care is that I want the result of the first thread. So when I run this code, well, in this case, the first thread finishes first, as you can see inside the console. And this is how the first structured task scope works. Well, as I have said, there are two kinds implemented with Java 21, with the early access builds. And the other one is the shutdown on failure. And the shutdown on failure policy states, I want to either all of my threads to succeed, or none of them do. So either all of them return something, but if one throws an exception, then I will cancel all the remaining ones. So again, I have this try with resource statement, but instead of the shutdown on success, I have the shutdown on failure, which doesn't take a generic. And I have again this scope. And from this scope, I can fork new virtual threads, just as the previous example. And then I have future objects that hold a reference to this, the value that I will get from these virtual threads. And then, of course, I have the scope to join. This will block till all my threads are done, or one of them has thrown an exception. I think both my threads will probably succeed. And then I have the scope.throw if failed. And at the scope.throw if failed, I know that I can check if one of my threads has thrown an exception. Because after the join, because at this point I know my threads are done one way or another, and then it's for me to check, did they all succeed or did one of them throw an exception? I can leave this, I can just also delete this line, it's also fine, but well, it's pretty nice to know if one of my threads has thrown an exception. And what this does is it will just rethrow the exception to the caller, and my method will exit at this point. Or if no exception has happened, I can just continue. So when I'm in the return statement, I know that my threads are finished because I have passed the join. I know that all of them finished successfully because I passed the throw if failed. And then I can use the future objects to get their result and return it. So now let's execute this. Let's just copy it. Oh yeah, can't return anything if it's a void. So let's try again. third time's the charm. And it prints result 1 and result 2. So with this print statement, I have printed both of the results of my threads into the console, which is really nice. And looking at the time, I do have time for a third example. So let's just throw this away. So the two built-in scopes are very nice. They, well, fit most use cases, but there are times when you need to create your own. And that's where the structured task scope comes in. For example, I created here a new class. It's called the criteria scope. And what this criteria scope does is my own shutdown policy. And my shutdown policy states that I want to shut down my scope if I find a product, if I do find a product, and if this product is worth less than 100. So I will just continue running threads, just continue spawning virtual threads until I found a product that is less than 100. So here I have just a very basic class that, well, shutdown policy really, that will just store my product temporarily, and then the handle complete is called by each virtual thread that finishes, either successfully or unsuccessfully. That's why I have to check for the state. And if my thread is done, or, well, I have found my successful thread that also returns a product less than 100, I, well, temporarily save my product, and then I can call the shutdown method, and the shutdown will shut down my structured task scope. So the product is just a very simple class that only has a price. So here I have my structured task, or my own criteria scope. It's again inside a try with resource statement. And then again, using the scope.fork, I create 3 new virtual threads that each return a new product. One will return a product with a price of 50, 300, and 100. And then after the scope.join, I'm going to see what the states of my virtual threads are going to be before I return. Well, and as you can see, I have run 3 virtual threads. The first one has the state of success because it's a product less than 100, because it is 50. The third one is 300, so it failed because I'm not really interested in a product that's worth more than 100. And as you can see, 200 also has success. So it did finish, but it wasn't a kind of product I was interested in. So my threads can still finish on success, but I also, well, I'm not really interested in a very expensive product. And so using or extending the structured task scope, you can create your own shutdown policy. And the pitfall really of structured concurrency is managing the lifetime yourself. Structured concurrency makes it just very easy for you to manage the lifetime of your threads. Well, just let it handle by Java, because then you don't have to maintain the code yourself. You know it will work, and it is a very easy way to manage your threads as a single unit of work. So I would really recommend using structured concurrency when it's going mainstream over creating something yourself. And what I want you to take away from this session is that to play with virtual threads, you only need these 2 methods, the start virtual thread and the new virtual thread task executor. This is all you are going to need to start playing with virtual threads, which I really encourage you to do. You can already use it with the early access builds, for example. You only have to enable well, the preview flag. But I really want to encourage you to start using them. It's really a lot of fun and really interesting what you can do with them. And I want to thank you for being here and for being such a brilliant audience. Are there any questions? Oh, then there was just, one.
The last sample you showed, so handle complete,
Yeah.
we could shut down complete that. But does that mean that implicitly, when all the tasks do complete, it will be shut down? Or like closed?
Let me just switch back to it. And what will happen is that every virtual thread will call this handle complete at one time. And then I have to check if their state is success, because in this example, I'm only interested in successful that didn't throw an exception. And then I have to do the other check for the product. But only then I want to shut down, because I only want to shut down when I found the result that I was looking for.
Yeah, I understand. But I mean, let's say nothing matching.
Then it will just shut down.
Okay, so there is an implicit shutdown.
Yeah, I do it here explicitly just because I want it explicitly to be shut down then and there. Yeah. Yes? Yes.
In one of your previous examples, you showed that you wanted to exit on a fake, right? So it was the second one. But I don't understand why you have to explicitly throw an exception. Use the method throw.
The throw failed. Yeah. Let's go.
Because from what I got from the code,
Yeah. If one of my virtual threads fails, then I won't see anything. Then the scope knows that a exception has happened, but I will just continue. So I have to check myself, or else I will find out when I try to get a result from this object, from the future. So yes, I can leave it. I don't have to do it, but it guarantees you that after the join and the throw have failed, then all my threads are finished successfully, and I can just access them as normally.
I thought shutdown on failure meant I would throw an exception with one of my.
No, yeah, you have to ask for it explicitly yourself. Yeah.
Thank you very much.
You're welcome. Any other questions? Okay, then thank you for being here.